Hi, period 8. So you guys are going to take notes today on the real number system. So the reason why we call it the real number system is when you guys get to Algebra 2, there is an imaginary number in math, and it represents the square root of -1. Because remember, you can't take the square root of a number, right? So if you type that into your calculator right now, you're going to get error. But in Algebra 2, in high school, you're going to learn about the imaginary number I. So when we talk about the real number system, that's why they call it real. So all the numbers you know right now are real. And we divide them up into rational or irrational numbers. So today I want to focus on the difference. So all of these inside this box are all rational. So natural numbers, whole numbers, integers are rational. Natural numbers. If I ask you guys right now to count how many kids are in our room, naturally you would start with 1. So those are the natural numbers. Whole numbers. So think of a hole in the ground. Usually they look like this. So whole numbers, same thing, but you start with 0. Integers. They are the whole numbers on a number line, and their opposites. Right? I know you guys think of the number line 1, 2, -1, -2. So when we say they're whole numbers, just keep in mind they can't be fractions, decimals, right? Because whole numbers don't include fractions or decimals. So again, these are all rational. These are irrational. Currently today, March 14th, Pi Day. So pi is the number 1 irrational number. The square root of 2 is irrational. 4.6791354002, that is irrational. Okay, so some examples of rational numbers could be the square root of 4, -2, 1/2, 1/3, 6.75. And I'm going to talk in a second about the definitions of rational and irrational numbers. So just make sure you guys are taking notes. Okay, so rational numbers, how am I getting these examples? Decimals can repeat. Okay, so that's why 1/3 I threw in as a rational number, because it repeats, right? 0.333. I'm going to just divide that up so we can see it visually better. So rational numbers are decimals that can repeat, can be written as a fraction. Or as a ratio. Also, what makes it rational is the decimals terminate. Right? So like here, it terminates, it ends. So either the decimal ends, the decimal repeats, or you can take the number and write it as a fraction, right? So -2 could be -2/1. The square root of 4 reduces to 2. So irrational is pretty much the opposite of rational. So the decimals do not repeat. Right, so like, obviously this does not repeat. Notice the ... means it goes on. So decimals do not terminate. They do not end. And they can't be written as a fraction. Okay, and if you guys have a calculator, if you take the square root of 2, it's a decimal that does not repeat. Okay, so those are like the top examples of irrational numbers. All right, so feel free to pause. You guys really should put this in your interactive notebook. Make sure you guys have all the notes written down. And then the next thing on the list is If you can print this, that would be best. If not, what you guys are going to do is you'll just create a T-chart and list which ones are rational, which ones are irrational. So what I would like you to do, and only spend, you know, after this video, maybe 40 minutes on this. Pretend it's a normal class. What I would do is before you color, I would write down if this is an R, rational or irrational number, and then go back and maybe just shade in which ones are blue, right? So blue is rational. And then please make sure you submit this to me in order to get credit. And it is due at 2:40. All right, bye guys. See you tomorrow.